Started. Okay. Very good afternoon. I welcome you all to this live session of the course Applied Thermodynamics. In this session, we shall discuss, questions that you have already, and we shall try our best to answer to your questions. In particular, those questions you are already having from the modules you have gone through. I'm sure that by this time you have completed a few modules of this course, and this particular session is kept exclusively to have some interactions among the students and instructors and other participants of this course. The course Applied Thermodynamics is an important core course to the students specializing in mechanical engineering, power engineering, chemical engineering, and aerospace engineering. There are many other branches of engineering sciences where this course is taught. In this course, several aspects of basic thermodynamics have been discussed. Besides, application of basic thermodynamics, for the system design, thermal system to be precise, has also been discussed. In this course, we have discussed about introduction to basic thermodynamics, then several modules, including internal combustion engine module, refrigeration and air conditioning module, steam power module, and gas power cycles. I would like to request you all to post your questions in the chat box, which will enable me to start interacting with you all to address your questions. There are, no questions as of now. I can see one question has been, posted by a faculty. This question is essentially on the blade profile of both impulse and reaction turbines. I would like to request Professor Mehta, having a discussion on the profile of both impulse and reaction turbines was a little difficult in this course, because in this course we had to cover almost all parts of applied thermodynamics. I have one suggestion for you to, go through any book on power plant engineering, and also the steam turbine books. As such, I can suggest you to consult with the book written by Kearton on steam turbine. Also, our Indian book is also available, wherein some aspects of blade profile design are detailed. Certainly, there will be some, changes as far as the blade profile is concerned for both impulse and reaction turbines, because the operation of impulse and reaction turbine is not same. In one case, we need to, employ the impulsive action due to changing momentum of the turbine jets as the high pressure steam having high enthalpy is allowed to pass through the blade passage. On the contrary, in a reaction turbine, both impulsive effect together with reaction mechanism is responsible to produce thrust in the course of flow of steam through the blade passage. In fact, I would like to mention here that very recently we have written a book on introduction to power plant engineering. We have tried our best to touch upon several important aspects of different components of power plant system. The book is supposed to be launched in the market by middle of September. It is being published by Pearson Press. I would suggest you all to have this book and kindly go through. There are several other important chapters included in that book, and those chapters are Introduction to Electrical Machines and then some control strategies. I would like to request all the learners who have joined this session today to post your question in the chat box. There are a few live sessions for this course. So this is the first live session, and I can presume that you have already completed learning a few modules of this course. And if you have any questions from those modules, kindly feel free to post your question in the chat box if you have any questions. The course Applied Thermodynamics, as I mentioned in the beginning, is an important core course to the students or undergraduate students of mechanical engineering, power plant engineering, aerospace engineering, and electrical engineering. This course is also offered to other branches of engineering sciences. In this course, several conceptual, paradigms of thermodynamics, basic thermodynamics, are used to design several thermal systems, used to describe several processes in different thermal systems. So this course is very important, not only for the students of different branches of engineering sciences, but also to the practicing engineers in power plant industries, several process industries, and since we have touched upon IC engineering module, so this course may also help to the practicing engineers of automobile industries. In this course, we have discussed about steam power cycles, basic cycles, several avenues towards the improvement of cycle efficiency, then several components of steam power unit, then their operational procedure as well. We have solved a few numerical problems to illustrate the conceptual part that you have learned from basic thermodynamics together with in theoretical part of this course. In this course, we have discussed about boilers, which is an important component of steam power module, and we have solved numerical problems which may help you to understand the design of boiler and several other components. We all know by this time that boiler is essentially a heat exchanger wherein feed water is allowed to be converted into vapor by taking heat, and we can apply the combined first and second laws to understand the thermodynamical aspects of the process which is there inside the boiler. We have also discussed about turbines, basic two different types of turbines, that is impulse and reaction turbines. And then we have solved a few numerical problems as well. We have established, blade efficiency through the blading diagram, and we had seen that efficiency of a turbine is highly important, essentially for the conversion of heat into work, because steam which is allowed to go through the turbine, the steam carries steam when it is entering into the turbine, carrying some heat, that is the steam is having enthalpy, and as steam passes through the turbine, at the cost of the enthalpy drop, we get some amount of useful work. Then we have also discussed about cooling tower, which is also an important component for the power plants. And we had seen that the overall efficiency of the power plant is largely dependent on the efficiency of the cooling tower itself. We have discussed about the operational procedure of a cooling tower. Then we had seen that what are the several critical aspects of cooling tower design, installation of a cooling tower in the context of steam power unit. As this session is limited to only a few minutes, I would like to request all the participants who have joined this session kindly to post your question in the chat box to enable me to start interaction with you all. I'm sure that you have completed a few modules by this time, and you will be completing the rest of the modules of this course in subsequent weeks. You will learn many other things, and since this course has been developed by myself and my colleague, you will find that remaining modules are also very important to understand several other, thermal systems, which, other thermal systems are also very important because they have, a lot many practical relevance. Certainly, steam power unit is very important. We all know that we get some electricity from the steam power unit. What we do essentially, we need to convert heat into useful work, and that work is essentially used to produce electricity. And in addition to this particular unit, there are many other thermal systems, other engineering systems, where thermodynamics, fluid mechanics, and heat transfer. So these three are important topics. These three topics are very much important to understand several processes in many engineering systems. I hope you will enjoy the remaining modules and you will learn how to design or how to design the system, different processes which are relevant to different thermal engineering systems. As I mentioned that this session is limited to only 1 hour. Please feel free to post your question in the chat box. And we shall start our discussion immediately. This applied thermodynamics is a very important course, another core course to several branches of engineering sciences and several branches of engineering science. And also this course is important to the practicing engineers. In this course, we have discussed several important components, their functionalities, identified several processes, and we have tried to estimate thermal efficiency of different systems. For example, if we talk about steam power unit, in a steam power unit, there are many components, major components, minor components. If you try to recall, the most important major components are boiler, turbine, then cooling tower, and feed water pump. In addition to these components, there are many other subcomponents. These components also play an important role for the overall performance of the unit. We have discussed about all these 4 major components. We have also tried to understand the essence of the feed water pump in the context of steam power unit. We have identified several processes. Those processes are very important to understand the total system performance and to estimate the efficiency. We have also discussed about mapping different processes, thermodynamic processes in different process diagram. The diagram may be PV plane. The diagram that it may be TS diagram, it may be PV diagram, it may be TV diagram, and all these diagrams are very important to estimate, to understand about the processes and to estimate the efficiencies. So as this session is limited to only a few minutes, I am very much thankful to Professor Digant S. Mehta for his comments, and I would like to request you all to email me if you have any specific questions to be discussed. Like the question posted by Professor Mehta is about the design of blade for both impulse and reaction turbines. I would love to have some discussion on this particular aspect on this topic with Professor Mehta, since it was not possible to cover this particular aspect in this course because this is basically applied thermodynamics. Had we designed a particular course on steam turbine, it would have been, better to, or it would have been ideal to discuss all these aspects in a greater detail. I would request all the students, practicing engineers, faculties who have enrolled this course with this course to write me, to email me, or to post your question in the discussion forum as well. So these live sessions are not only the sessions wherein you can really write your doubts, post your questions. There are, discussion forum. Discussion forum is also an integral part of this course. You will be having, a provision of writing or posting your doubts in the discussion forum. We shall be happy to discuss all these questions, in our subsequent days. So this is not only the platform wherein you have to have all the questions because you have completed only a few modules by this time. So in our subsequent days, we'll be having live sessions, and as I mentioned already, you'll be having a regular discussion in the discussion forum. So my suggestion would be to post your question in the discussion forum, and we shall be happy to take up all these questions for a discussion. Since this course is limited to only 1 hour, I request you all to post your question in the chat box. Since I have not received any question until now, I hope learners have no questions, no doubts, or it may be a case that they had some doubts and all those doubts, had been discussed in the discussion forum. I would like to have another few minutes in this discussion forum, and I would expect a few questions in this discussion forum. If I do not receive any questions, then I would like to wrap up the session for the day. I shall be waiting for another 5 minutes to know a specific comments, to know a specific suggestion for the course. It is not only the platform wherein you have to have some questions for our discussion. I request you all for any sort of suggestion that you would like to provide us for the course. I shall consider those suggestions, and I shall be happy to improvise the course or course material in terms of assignments upon receiving suggestions from your end. As I mentioned, this course is very important course for the practicing engineers. Students, mostly undergraduate students, are will be learning this course, and after learning this course, many engineers will be absorbed in different process industries, different industries including power plant, automobile, and process industries. During their profession as well, this course is expected to provide some insights to understand several processes in a real field. Considering these aspects, several modules of this course have been designed, and the course content are designed keeping in mind that not only these students of different engineering branches, but practicing engineer also will be benefited. I shall request you all to post your question in the chat box. As of now, I didn't receive any single question. I'll be waiting for another 3 minutes in this platform, and I shall be happy to discuss questions, doubts, if you will be having, and from the modules that you have already completed. Please feel free to post your question in the chat box. This will help me to start our introduction today. Certainly, you had some doubts. You are having some doubts. You will be having some doubts. As I mentioned, this is not only the platform wherein you can really, have the provision of, interacting with the instructor to get some answer to the questions, but there are many other, there are many other, sessions available, in particular in the discussion forum, wherein you also will be having a provision to interact with the instructors and to clear your doubts. This course, as I mentioned, is basically, the amalgamation of basic thermodynamics, fluid mechanics, and heat transfer. To understand several processes in different thermal engineering systems, you must know basic thermodynamics, fluid mechanics, and also heat transfer. So applied thermodynamics is very important, and to understand several processes, you should have, understanding of the concepts of thermodynamics. You will be having understanding of fluid mechanics and heat transfer. So all these three basic subjects are important to know more about this course, to know more about the content of this course, and to understand the, several systems which are very important in real life applications, and the processes inbuilt with all these systems. So being a student or undergraduate student, you are learning this course. After completion of your, degree, you will be absorbed somewhere in process industries. Therein, you'll be having some responsibility to know more about several components, to design several systems, and to improvise, several components. And for that, in addition to these three basic subjects that you have learned, this course Applied Thermodynamics will give you some insights into those systems. Since I didn't receive any single question today, and as I already mentioned, that you will you have many other sessions to interact with the instructors. You can write, you can post your questions. You also can write or email me the questions if you have already or you'll be having in subsequent days. So with this, I would like to wrap up the session for the day. And again, I should request you all to write to me or to email me if you have any, if you will be having any questions from the entire course of applied thermodynamics. With this, I stop here today. Thank you.